Hello learners, welcome to part 2 of our week 3 Physics Friday, Speed and Acceleration Graphing. So for this video we're going to focus almost exclusively on acceleration. So in part 1 we focused on speed and speed graphs, and in part 2 we're going to focus on acceleration and acceleration graphing. Alright, so we're going to start with just a basic acceleration graph. So here we're going to take a look at our starting speeds and ending speeds, and in our starting times and our ending times, and that's going to be something we'll repeat over and over. So as we can see here, our starting time is, starting speed is at 0 meters per second, and our ending speed is at 10 meters per second. Our starting time is 0 seconds, and our ending time is 5 seconds. So as you recall, to calculate acceleration, remember it's the change in speed divided by the change in time. And then we've also got the equation format of A equals S2 minus S1 over T2 minus T1. So when we input our values, we end up with our acceleration equaling 10 meters per second minus 0 meters per second divided by 5 seconds minus 0 seconds. So we end up with 10 meters per second divided by 5 seconds, which gives us 2 meters per second, which we write as 2 meters per second squared. Now this is the most basic acceleration graph you're going to see. Alright, the line is moving up and to the right. And this tells us that the acceleration is increasing, that it's a positive number. Alright, now let's take a look at what happens when our acceleration is negative. Alright, in this case the line is going down and to the right. Alright, so same thing, we're going to look at our starting speed, ending speed, starting time, and ending time. But as you'll notice, our starting speed at 0 seconds is 30 meters per second. And our ending speed is 0 meters per second. So basically, this graph is beginning where an object is already moving at 30 meters per second when we start the time. And then when we end the time, the object has stopped moving, which is why it's at 0 meters per second. Our starting time is 0 seconds, and our ending time is 5 seconds. So once again, we take our equation and we plug our values in. Now, this part you have to be very careful on to make sure that you are putting those starting and ending speeds and starting and ending times in the correct position within the formula. It's going to look a little funny, especially on this one, because as you can already see, we're going to end up with some negative values. So we get 0 meters per second for our ending speed minus 30 meters per second, which is our starting speed, divided by 5 seconds, which is our ending time, minus 0 seconds, which is our starting time. And so we end up with negative 30 meters per second divided by 5 seconds, which gives us negative 6 meters per second, or negative 6 meters per second squared. If you get a negative acceleration, what this means is that the object is slowing down. Remember, acceleration is a measurement of an increase, or in this case, a decrease in speed. So this is what this graph would look like. The final graph we're going to look at is going to illustrate the concept of intervals, which we looked at in part 1 with regards to speed. So many times when you're looking at speed or acceleration graphs, you're not going to be given a straight line like we saw in our first 2 examples. In this example, we actually have 3 line segments representing 3 separate intervals. And what we need to do is actually calculate the acceleration for each interval so that we can kind of tell the story of what's happening in this graph. So in our first graph example, we had an object that was increasing in its speed and its acceleration was a positive number. In our second graph, we had an object that was decreasing in speed, and so we had a negative number for its acceleration. All right, this particular graph is all over the place. All right, so let's take a look at this first interval. So for the first interval, our starting speed is 0 meters per second, and our ending speed is 5 meters per second. And our starting time 0 seconds, ending time 2 seconds. So this is pretty standard. We're just going to input those values into our formula once again. And so we're going to end up with 5 meters per second divided by 2 seconds, which gives us 2.5 meters per second, or 2.5 meters per second squared. Pretty basic, standard acceleration moving up and to the right, so the speed is increasing. But what's going to be interesting is this next line segment, this second interval. So, the starting speed for the second interval is 5 meters per second, but the ending speed is also 5 meters per second. Starting time is 2 seconds, ending time is 2 seconds. So, what does this tell us about what's happening with the speed for this line segment? Well, if we look at these speeds, it tells us that the object is still moving. It starts out moving at 5 meters per second, and it ends moving at 5 meters per second. So let's complete our formula and see if we can figure out exactly what that information can tell us about the object's motion. So once again, we're going to input our values into our formula. So we end up with 5 meters per second minus 5 meters per second divided by 4 seconds minus 2 seconds, which gives us 0 meters per second divided by 2 seconds. So we get 0 meters per second, or 0 meters per second squared. Now I want to be very careful here. This does not mean that the object is not moving. In a speed graph, that's what it would mean, that the object is not moving, that it's not moving any distance over a set amount of time. But remember, acceleration graphs are different because our y-axis is not a measure of distance, but a measure of speed. So the y value for both our ending time and our starting time is 5 meters per second. So if you have 0 acceleration, what this means is that the object is moving at a constant rate of speed. In this case, 5 meters per second. So for that 2 seconds, from the second to the 4th second, it was moving at a constant rate of speed of 5 meters per second. It was still moving, it just wasn't increasing its speed or decreasing its speed. All right, let's look at the third and final interval. So our starting speed is 5 meters per second when we start out, and then we end at 0 meters per second. Our starting time is 4 seconds and our ending time is 6 seconds. So once again, we're going to plug those values in, and because the line is going down and to the right, we know that we're going to get a negative number and a negative acceleration. So once we plug our values in, we get negative 5 meters per second divided by 2 seconds, which gives us negative 2.5 meters per second, or negative 2.5 meters per second squared. And once again, if we have a negative acceleration, then what we actually are looking at is deceleration, or an object slowing down. Its speed is being reduced over time. Now for your assignment. So for your Part 2 assignment, you are going to record 3 distances and times for different activities outside your house. If you're not able to go outside, you can do it inside as long as you get in touch with Mr. Beckwith and get it approved through him. All right. In this case, we're going to create 3 acceleration graphs representing the activities that you've recorded for your data. At least one of those activities and one of those graphs, you need to have at least 2 different intervals. All right, now in our example, we use 3 intervals. You don't have to use 3 intervals for that one graph that you're going to do the intervals, but you do need at least 2. All right, you can use the data from Part 1 to complete these graphs. So you don't have to go and do 3 completely new activities to get your data. You can use all of your data from that Part 1 assignment. If you have questions, remember you can always come to Digital CI or email me if you're stuck, and otherwise have fun with this assignment. Most of this are things we've done before, so it shouldn't be too challenging. There is one more video that will talk about how to put these graphs into either Microsoft Excel or Google Sheets if you choose to go that route. Otherwise, have fun, learners, and happy Friday.